Okay, what we're going to do now is deal with dimensional analysis. And to do so, we're going to start with a one-step problem where we want to convert 287 milliliters to liters. Now I happen to choose liter or a volume measurement in this example. But these rules apply whether you're measuring volume, which is liters, weight, which is grams, lengths, which is meters, and a whole host of other typical units of measurement. So we have milliliters, milligrams, millimeters. The actual unit being measured doesn't really matter in terms of these rules. So your first move in dimensional analysis is to convert the number given into scientific notation, which is 2.87 times 10 to the second milliliters. Including these units is absolutely crucial to the process. What you automatically do is you place that over 1. And we really haven't changed anything because anything over 1 is anything. So now what we do is we create a second set of parentheses. These are sometimes referred to as railroad tracks. As I've mentioned, I'm not quite sure I understand why they call it that. But what you're going to put here is you're going to put the unit ratio. So you put milliliters here, and the unit ratio is 1 times 10 to the third is the same as 1 liter. That's a unit ratio. Now what we're going to do is we say, okay, so that is equal to x. So what's x? X is what you're looking for. Now in the future, you don't have to put E equals x. That's implied. But it does try to clarify, where does this go? Now what we do is we multiply the numerator values together. And so what you get is you get 2.87 times 10 to the second milliliters multiplied by 1 liter. And then all of that is divided by 1 times 1 times 10 to the third milliliters. Now what immediately jumps out at us is we have milliliters on top, milliliters on the bottom, and milliliters over milliliters is 1, so we can cancel this out. Now if you look at it, you go, well, couldn't I have just canceled it out up here in the beginning? Yes, you could. And in fact, you are encouraged to do so because it makes it more efficient. But this illustrates why you can cancel it out and why you must recognize that the units on top becomes the same units on the bottom. Now, using the ideas of scientific notation, we divide this problem into 2 parts. We look at 2.87 divided by 1, and then we're going to look at 10 to the second divided by 10 to the third. And we work with those 2 events as separate events. And so you get 2.87, since 2.87 divided by 1 is 2.87, and you then multiply 10 to the, now 10 to the second divided by 10 to the third, we subtract exponents. So 2 minus 3 is 10 to the negative 1. Now notice the milliliters unit cancel, but our liter unit did not, and therefore we're going to include that. And indeed, that is the correct answer. Let's now take on a new problem. In this case, it's going to be a 2-step problem. And what we mean by a two-step problem is the following. Let's convert 552 milligrams of a substance to kilograms. Okay? Now, the first thing we do, as always, is take 552 and convert it to scientific notation, which is 5.52 milligrams, always so important to include units, divided by 1, parentheses. Then we create another parentheses. Milligrams on top means I'm going to have milligrams on the bottom, and I'm going to create my unit ratio here, which is 1 times 10 to the third milligrams is the same as 1 grams. Now at this point one's like, right, got it, but you don't. Your milligrams are going to cancel, cross cancellation. What's on top can cancel what's on the bottom, and that's going to leave you with grams, but I don't want grams. You'll notice I want to get to kilograms. So what you do is you do a second step. Now in this second step we create another unit ratio, and in this unit ratio you have grams down here, and 1 times 10 to the third grams is the same as 1 kilogram. Again, that equals X. We do not have to include that. Notice I can have my grams cancel with my grams, because what's on top cancels the bottom. Now, to keep this thing organized, let's do the multiplication. So what happens is my numerator becomes 5.52. Oh, Mr. Kurth, you made the same mistake. Gosh darn it. 5.52 times 10 to the second is the same as 552 milligrams. I'm hoping most of you while watching this film was saying, mistake, mistake. Well, I finally found it. So we're going to multiply our numerator across, and what you get is 5.52 times 10 to the second, and we still have our kilogram. Units. That's going to be divided by, multiply across, that's divided by 1 times 10 to the third times 1 times 10 to the third. Now you will notice there are no units down here because the units have all canceled out. So we exist just as numbers. Now what we're going to do is we're going to solve this bottom part. And when you multiply scientific notation, you multiply the two numbers, which will give you 1. When you multiply these here, you add exponents. So it's 1 times 10 to the 6th. So we multiply here, you add here. And that's under 5.52 times 10 to the second, and now the units do matter. Now we're set up with a divisional situation. So you take the two lead numbers here, you take 5.52 divided by 1, that's going to be 5.52 times, and what you see here is we have an exponential situation. So it's 2 minus 6, so that becomes 10 to the minus 4th. And now we have the ever so important units. And so this is an example of a two-step problem.